surge ahead in ESU testing. Smarter, safer, simpler. All right, today's speaker today is Justin Ross. He's our Senior Technical Sales Engineer from Fluke Biomedical. And before I turn it over to Justin, I'd like to go ahead and get a quick poll of our audience today. What is your level of confidence with ESU testing? Either low, medium, or high? And we'll just give you a few seconds there to answer that question.
All righty.
And Dan, as you can see, that poll question has been launched. We'll continue to give participants about another 30 seconds to enter, and then we'll close it, share the results, and then we will turn it over to Justin. So thanks everyone for your participation in today's webinar, as well as our poll question. And we're going to go ahead and close that. Let's see. And let's see, I'll share the results. Let's see, 38% indicated low, 43% of the audience indicated medium, and 20% of the audience indicated high.
All right. This is great, and thanks for doing that for us. The reason I wanted to do that as a start point is this is one of those webinars where we really want interaction. So you senior level technicians, as we're going through it, if you see something, please make your comments down there or put a quote or a question in the comment section. If we miss anything, what we're really going to do is we're going to go through all the common connections for a QES3 and show how they're going to work here on our custom built ESU. It's very nice. My wife won't let me have a real one in the basement, something about me catching myself on fire or something. I don't know, it's not fair. Anyways, so the next thing we need to talk about is these ESUs. And people get freaked out about ESUs a lot. I was a field tech for many years, and I used to have the same issue because I'd work on this model this week and a different model next week. And there's always confusion. Well, are my connections the same? For the most part, you got to remember that monopolar is monopolar is monopolar. And bipolar is bipolar is bipolar. So once you get the general connections and the idea of how you need to interface to the QES3, then changing out the model or make of ESU, it's really easy. So that's why we have a very nondescript ESU back here, because again, it's pretty much the same thing between ESUs, and it just comes down to the connector. The next thing is, what you can't see is I have all my cables that came with the QES3 laying on my floor. It's a very nice selection of cables. If you've lost some of your cables, feel free to go to the Fluke Biomedical website, and you can go underneath our accessory guide, and it'll pull up a picture of all the cables, all the test leads that came with the QES3. The reason I want you to go there and look for anything that's missing is because back in the day when I went through school, we used to take the pencil and we'd stick the pencil right into the QES3 or right into our ESU analyzer and discharge it. And that was accepted practice, but you know what wasn't really safe? We had a lot of exposed metal, and you could shock yourself or more so damage your analyzer. Well, then, you know, later on, I got smart and I would start to put an alligator clip like such onto the pencil. And when I did that, you'd have these itty bitty little teeth making contact with your ESU pencil. And they'd start to arc out, and you get some issues and corrosion, and it'd pop off, and you still had exposed metal. So again, not a great idea. So when I go into biomed shops and I work with people with their ESUs, a lot of times I see them trying to use that pencil or trying to use this. And when I ask why, two reasons. Well, we don't know how to set up the ESU analyzer. Didn't know there was a different way. B, we didn't know there was a better way. And C, well, we're missing some of our cables. So feel free, go to that connection guide, look for your missing cable, give your rep a holler, and they'll help you out getting you the right cables that you might be missing from your kit. Or you can buy the entire kit, which is also really nice because, in my opinion, you can never have enough test leads. All right, so let's get cranking. We're going to start working right here, right off the top of that guide. So does everybody have a chance to pull that guide down? If you can, it's so nice to print it off in color. This has been a guide we've had around for a few years. We've had a few different revisions. Some of the other channel partners, Southeastern Biomedical and Phoebe, contributed and brought their ideas in, and we made this real nice new version, and it's on our website underneath applications. So feel free to download this or out the notes today. And this is going to be a good connection guide for you. So let's start off with contact quality monitor testing, or CQM. Now, a lot of you might know this term as REM, or return electrode monitor. So REM is a trademark term. It's owned by Valley Life Covidien, but the IEC generic term is contact quality monitor. And true story, when I first started teaching this, I couldn't remember that, so I used to have to write it on the palm of my hand. I can now show you that I've now remembered what CQM stands for, and I don't have to do that anymore. So what is CQM? So CQM is where we're going to attach 2 pads to the patient's chest or to the patient to return the energy back in. So there used to be 2 different styles. There's a single foil style and a dual foil style. We're going to talk about the dual foil testing, and we'll touch on that single foil here a little bit more. But CQM, REM, same thing. How we're going to test for it is if you look in your cable kit, you're going to have this very nice cable. It looks like this with a red and a black on this side. And on this side, it's going to have this DIN pin. This is for a dual foil cable. You may have one of these, or you may have adopted one over the years that's a single foil. It just has the one black connector on this side and no DIN pin on this side. We're going to focus more on this in the future, but for now, this is the one we want. Okay, so this is the nice thing about the QAS3. We're going to go to F4. Let me zoom in here just a little bit on my QAS3 here. Now, I got a new camera the other day, so I'm very sorry, but we're washing out the screens here a little bit. If you have specific questions about what's on my screen, go ahead and type it in, and I'll try to answer them for you here. So we're going to go to the CQM screen. Now, what that allows you to do is we now have a built-in rheostat that goes from 0 to 475 ohms by single ohm increments. Now, usually CQM testing is done right around the 130, 150 ohm range. So why do we go to 475? I really don't know. I guess in case we're going to make an ESU for an elephant or something, but we're capable of going really high with that. So now how to test it. So CQM, we're going to go black to black. And then you'll see right here, there's 3 sections on my ESU. There is a switch section we'll talk about here. There's a load section, and then right here is a CQM port. So black to black and testing CQM. Now this side, we're going to go into the face of our ESU. And you'll have a port over here that looks like this, and you'll plug this in to the front of your ESU. Everybody able to see that okay? There we go. And once we're there, we're going to go ahead and we're going to follow the service manual. Now you're going to hear me say this a lot of times today. While this setup is common, the specific resistances that you need are going to be outlined in your service manual. So you'll typically see something like right around between 7 and 135 ohms. So you'll run this up to like 130, 100 ohms or somewhere in there. And sometimes you have to unplug it to reset the ESU, and then plug it back in. And once you plug it back in, you'll roll this up slowly, and eventually the ESU will alarm. And then you know at what resistance your ESU high end of your CQM is set for. Usually right around that 135 ohm plus or minus 2 or 3. And again, it's going to have you do it way down low, somewhere around 7 or 8 to see where the low end of that resistance spectrum is. And again, that's going to measure the resistance between his 2 foils attached to the patient. We'll talk a little bit more about that here if we have some time. Hey, please listen about those questions. Please make sure you're sending questions today because this is about helping you all out. So if we're missing something, please feel free to ask it. I want to make sure that we get everybody nice and comfortable here. CQM testing. All right, let's move on to page 2 here. So we talked about CQM configurations, the single and duals. So let's talk about this for a little bit more because this is going to play into setting up our monopolar output. So our 2 cables. If you look on the front of your ESU, you might see a symbol that looks like this with a solid black bar in the middle showing a single foil. Or you might see an icon that looks similar to this where it has 2 little black squares in it, meaning that you have a dual foil. So in monopolar, you have your pencil that's going to be putting out that high energy. It's a single, it's like a DC path. So what goes in has to come back out. So the high energy comes this way, out through the pencil, into the patient to cut, cauterize the tissue. The energy needs to be collected and sent back to the ESU. So that's done through that REM or CQM pad, that single foil pad. The problem is that some of these cases that we're doing on patients can be very prolonged, and that pad can start to come off over time. So when you start off with this big area, you have real low resistance, and there's no way that you're going to get a good patient. You're not going to be able to get a patient burn there. But over time, as that pad pulls off and you shrink down that area, the smaller the area, the more energy has to go through that area, and all of a sudden you might have your energy going through a very small little space, and that can cause a secondary patient burn. I got to tell you, of all the things I want to know that work on the ESU, it's the CQM test. And ironically, I see a lot of biomed skipping it because of not knowing how to set that up. The reason this is so important to me is I only want to be burnt onto surgical site. I don't want to be burnt where they stick that pad, which, by the way, is typically on your backside, either directly opposite of the surgical site or down on one of your legs, flanks, or backside of the, that area. And I don't want to burn there. So the CQM testing is very important because of that. So as that pad pulled off, somebody said, well, hey, we got to make sure that this pad isn't coming off. And what happens is after they put that pad on the patient lays down on the table and they cover you up and they prep you for surgery, and you can't see that pad anymore. So you have no clue if that pad's getting pulled off. So the idea is then when we went to this dual foil pad, we can now measure the resistance between these two foils. So the REM or CQM built into your ESU is going to say, hey, how much resistance is between these two foils? And as long as it's within a tolerance, it's going to go ahead and let the ESU operate. So when you plug this in, you'll normally see this light will turn from red to green saying, we're good to go. And that's how that dual foil pad's going to go. And then if that pad starts to rip off, that resistance is going to go up, and this will turn red and shut down your ESU functions. ESU is still on, it just won't allow you to operate. Back in the day, way back when, a lot of things were single foil pad, and we could test with single foil pads. If you have a modern ESU that was just released within the last few years, you're going to notice when you're doing your testing, if you're not in service mode, it's not going to allow you to operate that single foil mode. This icon doesn't even exist on very many ESUs anymore. Only thing you're going to see is this dual foil pad. So you're going to have to use this. So this is the dual foil pad configuration. And then in your box of goodies, you'll find this. It's going to look like a little fuse holder. In fact, what is in here is a little resistor. And so what we're going to do is we're going to put this resistor, and I lovingly call this my man in a can. We're going to put this resistor in line like this. And this is now going to simulate the resistance between those two pads. And by doing so, satisfy that CQM requirement of your ESU. So now I'll set this up. So if I plug this back into my ESU, like so, and I have this cable in place, this light will turn to green. Once that light turns to green, I'll be able to activate my ESU. So now I'm going to plug in one side of this. So now we're going to talk about monopolar ESU testing. Before I move into there, was there any questions on this setup or CQM? We got anything popping in there, Mr. Dan or Edna?
No, not at this time, Justin.
Whew, that must mean I'm doing good.
Yeah, but
Or y'all fell asleep.
Audience, yeah.
All right. So here we go. Now we're here. We're going to go right back into that monopolar. Don't hesitate to put the questions in. There's no silly question, only ones unasked. I like to color code things, so I'm going to go black to black, right into variable low. So this part is now set up. So without getting into service mode, if I just want to check this ESU in normal operation, this satisfied that CQM requirement. So now I'm going to go ahead and I'm just going to pretend we're going to test monopolar 2. So if you look at these ports for monopolar, you're going to notice there's 3 similar sized holes in it, 1 by itself and 2 that are together. If you look at your handpiece, you'll notice that there's 2 buttons usually in your handpiece, a yellow and a blue. One's for cut and one's for coag. The way it works is when you push the yellow button, it jumpers the yellow button to the red, and it activates the energy output. The one that's by itself is usually the energy output. So yellow, if you activate yellow, it trips this to this and turns on cut. If you do coag, you'll trip the blue, push the blue button, and it'll trip this and connect it to red, and your coag will turn on. So if I have the foot pedal in my ESU, the only thing I need to do then is take one of my red cables, and I like to use these ones with the piggyback. This is great for this. And I'm going to mention something. These are a specific length for a reason. The next thing I should probably mention is as you're doing your testing, you notice that my ESU is not sitting on top of my analyzer. If you do this, a lot of the frequencies we operate now are just below RF energy. So you can actually transmit radio frequency from this to your ESU and skew your answers. So you want to make sure these two devices are not stacked on top of each other and that you're not adding length to these cables, because if you do, you just turn this thing into a radio antenna and you can transmit your signal out. So back to my red cable. We're going to go red to red. We have one side of my REM disabling cable connected in the very below. That over here, and I'm going to simply take this red to the port that's by itself in that monopolar connection. That will turn on the ESU. I will now take my cut up to whatever I want to test at, normally max, and my coag the whole way up, Then on my QAS3, since I was in CQM, I'm going to push the back button. I'm going to go to generator output. And typically, if I'm going to be testing cut, it's at what, 300 ohms, and coax at 500 ohms. So I'm going to take my resistance and I'm going to use this knob and turn up to 300 ohms. I'm going to push start continuous on my QAS3. You might hear it turn on here. I'm going to put my mic here. When I do this, it's going to turn on a bunch of fans. You guys hear that? All right. Once this is on and working, I'll use my foot pedal and I'll trip cut. Beep. And on my QAS3, I'll get my power in watts, my current in milliamps, my peak voltage, and my crest factor. And then I'm going to let go of my foot switch. When I'm going to test coag, beep, step on the foot switch, activate coag, and get my measurement here. Oh, thank you. Forgot to do something. Cut was at 300. I'm going to hit stop, take my resistance to 500 ohms, start continuous, and then step on my foot pedal. How do you know that if you made a mistake like that? Because all of a sudden you get wackadoodle readings that aren't within the spec of your service manual. Again, this is a great place to have your service manual open to know the exact resistance you're supposed to set at and what your output reading should be. When I was a young tech, we'd always read everything in watts. Everything was in watts. But as you read modern service manuals, you notice that a lot of things aren't written in watts anymore. You're checking for the amperage output. The QAS3 shows it in milliamps, MA. A lot of your readings will be, a lot of the manuals will read it in amps. So you're going to have to move that decimal point over 2 positions. Just a little hint for you though when you're checking your outputs. Okay, so that's how I'm going to check this monopolar ESU. How often do you actually get the foot pedal back with the ESU when they say it's broken? I was never usually that fortunate. A lot of times what would happen is the foot pedal would get lost or broke and they're running one foot pedal between the ORs, and we never had enough foot pedals. So when I had a broken ESU, I never had a foot pedal to test with. So how can I trigger this ESU now with no foot pedal? So you notice this top section up here and the QAS3, it says switches. And you'll notice these last 2 ports over here in monopolar too. So this is pretty cool. If you look in your bag of tricks, cables, you're going to notice there's 2 additional cables, a yellow and a blue. So I'm going to put blue here to my coag, and I'm going to put yellow to my cut. Now a little bit of a hint for you. If you're working on a Valuelab, Covidian, Medtronic, whatever you want to call them there, the 2 ports are inverted. So here while the blue is on the right, here the blue is actually on the left. The coag's on the left. Cuts on left, cuts on right. So I'm going to go ahead and hook these up here like this. Now you're going to notice We have a missing hole right here, and this is the trick. If you can remember this step, you got this lick from here on out. This is the one that trips everybody up, myself included when I started. There's one more port, and it says common. Remember when I told you how we're going to activate this? If we're going to push coag, we're going to jumper from coag to the hot. And if we're going to activate cut, we're going to jumper from the cut to the hot. The key word there is jumper. So if you look back in your bag, you'll find another little jumper cable. And we're going to plug that into the common like such. And we're going to jumper that to the back of the energy output hot. So I'll take this out. This is what it's going to look like. This is why you have these stackable connections. And it's going to go right here into variable high. If you want to see this in your handout, you will be on the second part of page 3 right here. This is where it's at. Picture's a little hard. You might have to zoom in a little bit, but the colors are listed over here in the text. So there we go. That is how we are going to jumper this in. Now, I need to tell you something. If you do this, when you do this, we have 2 features here. I have to move my wires out a little bit. We have start single and start continuous. There is a duty load or duty cycle for your ESU. It's only for so long, and the duty cycle for the ESU is less than the duty cycle for the QES3. If you hit start continuous, it's going to turn on the ESU and, turn on the QES3 and the ESU to hit stop. If you exceed that maximum duty cycle on your ESU, you could damage it or overheat it. So I recommend in this case using start single. So in this case, I have cut selected. I'm going to push start single. It's going to turn on cut in my ESU. And you notice that my ESU just shut back off, my QS3 shut off, and I'll have my readings right here, the power and the current, and it'll keep it on the screen for me. That duty cycle is only 2 seconds long, enough for you to get a stable reading. Great question. So if you do have a suspected dropout where it's been running for a little bit and the signal drops out, you can do start single. But again, be mindful of that duty. You can use start continuous and leave the QES3 on and it'll run the ESU, but you have to be mindful of that duty cycle so you don't hurt or damage that ESU. And to stop it, I'll hit stop on my QES3. Another great question. Thank you for asking. Dan, you are really good on the questions today, buddy. So what's going to happen if I mix these 2 up? And I don't remember this is on the left and this is on the right, or vice versa. Simple enough. Here we're on foot switch above F2 where it says cut or coag. If I have these 2 wires backwards and I select cut and I hit start single, the only thing that will happen is coag is going to turn on instead of cut. And you go, oh, sorry, flip-flop these 2 wires and try it again. That's all that's going to happen with that. All right, I'm going to pause there for 1 second. Miss Edna, any questions coming in, ma'am? All right, I'm not hearing any questions. And the other reason I had to pause is because I realized that I forgot something on my desk on the other side of the shop.
No worries, Justin.
I'm back though.
We did get questions, and one question is, what is a duty cycle? And before you reply to that, I just want to remind everyone that join the handout that Justin has referenced is available in the handouts tab in your dashboard. So please click on handouts, and there is a PDF that's available there. And then I also included a message in the chat where you can download the handout. There is a link included there if you have questions. So once again, Justin, the question is, what is a duty cycle?
What is a duty cycle? A duty cycle is the amount of time that they recommend the device to run. So for instance, if you have certain motors or things and you run them for so long, they get hot. So you can only run them for so long before you have to let them, you have to shut them down and let it cool down. The same thing in the ESU. In the ESU's manual, it'll tell you how long you can cut before the inside of the ESU heats up. A lot of the modern ESUs, that duty cycle has been extended because they've added fans and things to keep the circuitry cool. In the older ESUs, not the case, and you have to be mindful of that duty cycle. Because if you ran it for too long, it's going to build up heat in these components inside, and it can actually start to damage them. So that is something to be mindful of. You don't want to just hit start continuous and walk away and get a cup of coffee, because it will probably melt down your ESU at some point in time before you get back. I hope I answered your question. That was a good one. And any more? I like questions.
There's one more.
Oh, cool.
Okay, if you are only verifying the max output from monopolar, then how do you know if lower output values are in tolerance?
Oh, that's a great question. You absolutely don't. You absolutely don't. And this is why I refer people to the service manual. Way back when, I'll admit, when I was first trained as a technician, I got out into the field. That's one of the places that I worked at. That's they did. They just check the low, a medium, and a high. If you look in your service manuals, you might find it's going to request that you test multiple points. Every so many watts off the scale, it might just have the high end. Some people accept that. Some people want to test more and make sure that it's doing the full scale. I encourage you, if you suspect that your ESU could be having an issue, test multiple points. Check your cut at 5, 10, 15, 20, whatever that increment is that you feel necessary, or your service manual dictates. So that's a great question. Yeah, we do a lot of assuming in the field that if the worst case scenario works, that's going to work on the full scale, but it's definitely a good thing to check that full range, especially if you suspect that you're having an issue with one of your ESUs. Yo, that's a good one. I like that one.
All right. One more, Justin, before we move on.
One more.
Okay. Is it necessary to go to service mode device under tests?
Ha! Well, that's a great question. I just turned on this ESU, my paper ESU, 2 times without going into service mode. I didn't even get into service mode yet. So no, you don't have to, especially if I want to test to see how it's working in the field. If I had a patient incident and I can sequester all the supplies that were used, I'm going to want to test that the same way it was used in that case. So in which case I wouldn't be able to get into service mode. And that's one of these great reasons why I can activate it with this foot switch system here, or I can activate it with just a handpiece. And I missed something in this manual. So I'm going to take that as a segue. I'm going to go back and show you one more connection for monopolar, because we talked about monopolar 2 over here, where we had the normal pencil output. But a lot of times monopolar 1 will have a handpiece adapter. So you'll need something that looks like this. Now, this is not something that Fluke sells. These typically come with your ESUs when you first get them. And this is where you put the handpiece or different ESU, different surgical instruments connected into this port. And then this would sit right here in the front of monopolar 1. So I have 2 versions of this. I have an older one that had a thumb screw, and I could just use my normal red cable. But with this one, the port is a little bit small, and I have a hard time getting good conductivity. See, it doesn't go the whole way in. So something I found I can do, if I go back to my bag of tricks, I can pull out this cable, and this is the bipolar activation cable, and it looks like the banana pin got knocked off. And I like to put that in here, and that makes good contact with the in there. And I can put this right into this, like so. And then I'm going to unplug monopolar 2 here. Get monopolar 2 out of the way. Why am I using my floor? Just like all the rest of you, I ran out of bench space today. And I'm going to plug this into my variable high. Now I could turn on monopolar 1 and activate it with the foot switch. If I can't do that, that same way I did it over here with my yellow and blue, I can just as easily take this yellow and blue setup again and put this back in and set up monopolar 1 the same way, like such. I know I put a hole over there. There we go. And one more time with my little jumper cable for my common. Uh-oh, there's an issue. There's not a jumper on the back of this bipolar activation cable, but there's one on the back of my jumper cable. So I just flip-flop this order like this, boop, and plug into my variable high. And now I can use that foot switch combination to activate through monopolar 1 with a handpiece adapter. Ta-da! Man, I really wish I had better jokes. Okay, that's monopolar. We are at halfway point. So I'm going to
Justin?
go ahead. Oh, yep. Yes,
I'm
please.
sorry, because questions are coming in.
Nope.
Are you okay if we take one more really quick before you move
Well,
on?
yeah, I love this.
Okay,
Yeah,
wonderful.
please.
So this question is from Ashley. Thanks for submitting your question. I was
Mm-hmm.
curious if there were any differences in the color cables. For example, what would happen if I plug the yellow cable into the monopolar output?
Nothing. They're just test leads. We just color coded them to help make it easier for you. They all have similar resistances. There's similar lengths. There are some short ones and some long ones for different applications, but any of the cables will work. It's just easier for me to color coordinate. I have a blue pin here. I have a blue port here and a yellow port. Well, if I stuck a red cable in my blue port, I get confused with stuff like that. So I try to keep things color coordinated just because it helps me remember that I put all my right cables in. But if you have to, sometimes you got to do what you got to do. And you can put a different cable in here. You just have to remember where you plugged it in on this side so that you put the appropriate end in the right port on this side. All righty, I'm going to show bipolar. Bipolar's fun. I like bipolar. Okay. No jokes are said about the bipolar. All righty, here we go. So, way back in the day, oh, by the way, we're moving on to this page, bipolar connections. It's going to look like this. Okay. So, way back in the day, and the older ESUs, when you're doing bipolar, you didn't have to worry about this REM CQM. Because in bipolar, the energy that comes out of this port is alternating and going back into this port. So typically bipolar instruments look like forceps or needle nose, pliers, or they'll have like a loop for removing polyps. So the energy's bidirectional, AC, and it's going to bounce back and forth in between two little points. This is usually for use for microsurgical applications, small micro. So this wasn't necessary. You didn't need to have a REM pad connected. Everybody who's running these modern ESUs, force triads, FT10, FX8s, geez, there's a whole bunch. I'm drawing a blank on some other ones, but long story short now, if you have bipolar, it's going to require you to use the same setup to satisfy this REM cable. So I'm just going to leave this connected to satisfy my REM, and I'm just going to set this down like such. Hey, everybody who's about to ask a question about and never talked about how to do monopolar in service mode, I'm intentionally ignoring that. I will be coming back to that. So everybody who has questions about the FT10s and triads in service mode, I didn't forget about you, I promise. Okay, so now if you look in the bipolar port of the ESU, you'll typically have at least 2, sometimes 3, and sometimes 4 different little ports. 2 larger ones and 2 smaller ones. So bipolar is pretty easy. On the front of your QES3, you have a variable red, a variable high, and a variable low. On your ESU, we're simply going to do this. 1 to one side and 1 to the other side. Now, my resistances are going to need to be altered. Typically, it's between 50 and 100. So I'm going to turn my resistances way down to 50. If anybody has your QES3 in front of them, they're going to notice if they go slow, we jump by small increments. If we go fast, it starts to jump by larger increments. It goes the whole way up to 4,500 ohms resistance. Everybody who's about to ask about the 5,000 ohm resistance that they need or 50 ohm resistance, we'll talk about that later on. That's another good thing to earmark, remind me about. So right now, let's go down to this 50 ohms. There we go. 50 ohm resistance. Now, all I'm going to do is hit start continuous on my QES3, turn my bipolar to wherever I want it to be. Again, reference your service manual for your ESU, use my foot pedal and activate bipolar. And I get my my power, my wattage, and my peak voltage right here in my QES3. And then press stop, attend the test. So that is nice and straightforward. Okay, so now what happens if I don't have that foot pedal? Well, remember that little bipolar activation cable? And I got a nice picture of it. My buddy Dan, who's part of this webinar there, he got this really nice picture of it, and he added it right here for you so you know which one it is with the part number in case you lose it. So this is that bipolar activation cable. We use this in that prior step in the monopolar handpiece. Those other two little ports, grab one of them. It's usually the bottom one. And that's where that little pin's going to go. And then this, we're going to put right back into the foot switch side. We can choose cut or coag. It doesn't matter which one we choose. So let's just go ahead and we'll put this in cut. Whatever we choose here, down under the foot switch selection, we need to be highlighted. So cut here, cut here. And once again, that leaves this poor common port all by itself. And just like before, remember I told you, remember this once, remember it again, you need the jumper. So we're simply going to jumper from common right here to the back of variable high. And then what we're going to do is we're simply going to push start single. This will turn on and your ESU will turn on. Great question. If nobody's asked this question yet, I'm sure somebody's about to. They've tried this before and they got no readings on their QES3. There's a reason for that. A lot of these ESUs have a diode in there, which directs which way the energy output can come. And if you don't have the right reading or your readings are very low or you're not getting any reading, this is simple enough to fix. Simply take these two wires and flip-flop them like such. Now I had red on left, now I have it on the right. I just flip-flop those two cables and try it again. And then you'll probably get your reading that time. Nice, simple fix. Oh, that reminds me. Hey, I need to tell you guys something. You'll notice on a lot of these cables that they have sheaths. You see this right here, this little white plastic or clear plastic? And when you plug this into the ESU, it pushes that sheath down and exposes the metal. This is a safety feature, so you can't touch the metal and accidentally get shocked. But if you have a brand new set of cables and an older ESU where these ports might be getting a little bit wore out, what you might notice is that these cables will auto eject, meaning I'm going to put this in here and I go to try it and nothing's reading or won't even turn on. A lot of the ESUs now have built into these ports little micro switches. So it needs to know that there's something in there before it allow that port to turn on in the ESU. So if you plug this in and it's not the whole way set into your ESU, that switch may not be depressed. Or you might have it depressed and let go, and that spring built into the sheath of the cable is going to auto eject it either the whole way or just a little bit. So if you set this up and you're not getting readings, take a breath, take a second and look at it again. There's a good chance that one of your cables popped out, and just make sure they're good and set in, and then try it again. And that'll fix it the majority of the time. Yep. And then you can flippity-flop the two cables if you still need to. Check that out. We just did bipolar.
Justin, can we take a couple of questions?
Of course we can. I love
Okay.
this. Is great. Are you guys liking asking questions? I love that people are asking questions.
Okay. So the first one is from Daniel. And Daniel, thank you for submitting your question. Is this applicable for testing all medical equipment?
Oh, I'm not sure I understand. We're testing ESUs there, sir. Can you define your question a little bit more, please?
Yeah. Okay. Thank you. And then another question came in. Those cables, how often do they need to be replaced? Is it every year?
No. You need to replace them when they stop working for you or they break. I don't have any here. One of my demo units has a broken cable where it got pulled out. Every now and again, just from over usage, you might have a cable break, and you can just get on the Fluke site and check them out. If you suspect that your cable's starting to fail, replace it. If you want to test to make sure your cable's good, this is simple enough to do. Only thing you have to do is grab your multimeter. I know a lot of us don't even remember what multimeters are anymore. All the old guys are laughing. I didn't say oscilloscope. Multimeter, and go to the continuity test and simply check the continuity between this pin and the pin over here, and make sure that you still have a good cable. You know, you probably want something less than a half an ohm or so. As these get wore out, they can break down over time, but replace them as they go bad. This set, I've probably had this set of cables for, oh Lord, 8 years, 9 years at least. Yeah, they're all still here. I've had to replace ones or two that have broken, but yeah, just when they break is when you have to replace them. That's a neat little feature. Maybe that's a future webinar. That's a really cool thing that you can do with your safety analyzer. It's point-to-point testing and measure the resistance between 2 points, and that'd be a great application for it. We'll have to talk about that in the next time we talk about safety analyzers. Any more? I like this.
Yeah, sure. This is from Alan. What is the purpose of the RECM alarm disabling lead?
To satisfy this REM. So we're not in service mode right now. So to satisfy this REM CQM, this is simply going to simulate the average resistance of a human being across between these two pads. And once you plug this in, your REM alarm will go green. All right, so listen, we need to talk about ligature still and cross coupling and service mode, and we got 15 minutes left. So I'm gonna keep moving for right now because I want to make sure I get through everything and I don't get yelled at by Miss Edna. So that said, we're gonna go right in here into ligature. Keep the questions coming. If I don't get to them now, we will answer the questions and get back to you. I promise, I promise. Okay, ligature. Does everybody know what ligature is? I'm gonna say some do and some don't. Ligature is another form, and it's kind of cool because ligature with an S is a trademark of a manufacturer. Ligature with a T actually tells you what it does. So what it does, it's a form of sealing a vessel. So we're going to use the ESU's energy to create heat. So the ligature usually it's an endoscope instrument. So it's on the end of a stick and there's a little pair of forceps in it. So an example is if I'm going to be removing an organ, a heart, liver, spleen, the blood flow to it, I'm going to grab hold of that blood vessel, clamp down on it with pressure, and then activate ligature, which is going to heat up those tips and seal that vessel closed, like glue it. And then there's a little knife blade that will cut that vessel, and it is permanently sealed. I can't open it again. If I need to open that vessel and I sealed it right here, I need to go further back in the vessel and cut it open again. But this is how you permanently seal off that vessel so it's not bleeding. So that's what it does. Now, back in the day, you used to have a special adapter to plug into here to test ligature. Now it's a little bit different. If you look back in your bag, there's going to be 2 more cables, a black and a red, and you're going to notice they do not have the jumpers. Okay? So no jumpers on these ones. And the reason is this port is really small. So what we're going to do is we're just going to simply plug these into the 2 outside holes. You're going to notice there might be a bunch of smaller holes in between the 2, but the 2 outside larger diameter holes is what we're going to plug into. And then again on our ESU analyzer, variable high and variable low. Oh, my ESU is sliding. Okay, now we need to talk about one more thing here. All right, 2 things have to happen. If you read the service manual, for everybody who knows their service manual inside and out, you're going to say that some of the service manuals say use the generator output feature and go to 200 ohms, and that works. So I can stay here in the generator output screen and go to 200 ohms. But we're changing the frequency of the energy. So while you get a reading here, a better way to get a more accurate reading is to back out of this screen and go into the vessel sealing screen, F2. Then apply your 200 ohm load. This changes the way the ESU reads that energy and gives you a more accurate measurement. So change this to vessel sealing here. Now on your ESU, there are different pencils that have different energy ranges. So it's not going to recognize this. We have to go into service mode. I'm not allowed to tell you the service code. Read your service manual. It's in there. Get into your service mode. Go to the RF energy output tests. Activate the ligature port. and follow the manual to the exact outputs. Some might be read in levels, some might be read in watts. Set that appropriate level. Start continuous on my QAS3. On my ESU through the service manual, I'm going to push activate here. Start continuous here. Activate through my service screen, and I'll get my reading in milliamps on my QAS3. I'm going to go ahead and hit stop. So the fan shuts off. And then I have to deactivate on my ESU. Don't forget to deactivate your ESU. And then I'm going to go to the next setting. So that's ligature. Nice, straight, simple, just about as easy as the bipolar, but you had to go into service mode. Now we're in service mode. Let's go back and talk about all the other service mode tests, because a lot of you are servicing these FT10s and triads and FX8s, and you're used to going into service mode. So that said, in service mode, you can get away with using the single foil pad configuration. So I'm simply going to connect this into variable low, and I will connect this into my port on my ESU. When I teach ESUs to a lot of people, I don't even bother with that. I like to show this. But there is the chance that one day you're going to overactivate or mess up and plug in both these ports and blow this resistor. You'll know when it goes apart, you open this up and the resistor is going to be gone. So you have to buy a new REM, but you still have to test your ESU today. So yet another way, I can simply connect this into my REM port, go into my service mode, and then for monopolar, it's just as simple as one additional cable, variable high to monopolar output. I go back in my QAS3, and I'm going to go back to generator output, put my appropriate resistance in it, start continuous, select my appropriate port with my ESU, and activate monopolar 2 and get my readings. Same thing with monopolar 1, but I might have to use this adapter again, just like we did before. Same thing with bipolar. I'm simply going to go down to here. And I am going to do the same configuration as last time. Disconnect this, connect this in, take my resistance down to 50, start continuous here, select the bipolar port with my ESU, select energy, and hit start continuous on my ESU. Stop. Okay, we have 10 minutes left. I'm going to go ahead and take a few questions because there's two things we have to still talk about. We have to talk about high energy output and cross coupling. Fire away, Miss Edna.
All right, JR, we did get more questions, and this relates to CQM. So you ready for me? Because this is the old school question. Okay.
All right.
Does the CQM replaces a decade box, or do I still need a decade box?
Paul, it replaces it. You don't need it. It's built right in here into your QAS3. If you have the older QAS2, you don't have it. You got to make sure you have a QAS3. Which is also nice because at the end of the year, those decade boxes, I had a tendency to blow those up. But now I only have to calibrate one device instead of two. Yeah, built in.
Okay. Alrighty. This is from Matthew. And this is pretty long, so bear with me. I have seen contact monitors with a pin and some without one, as well as manufactured literature calling for on or the other specifically. What is the difference between the two?
Oh, great question. So I didn't say ARM in this presentation, did I? I think I put it in here. ARM is another trademark similar to CQM is the generic term. REM is trademarked by Valab Covidian. ARM is a similar thing, pretty much the same thing, trademarked by another manufacturer of ESUs. And boy, golly, I'm drawing a blank on the name of them right now. Same thing, just different manufacturer. With the ARMs though, typically you want to test them going down instead of up. So read the service manual, but it's all the same. CQM, REM, ARM, all the same thing. The difference between the pins, again, and your pads, if you have, I don't know that I have a pad in my office anymore. If you look at those pads, if you look at your REM pad, arm pad, CQM pad, if it has this little divot DIN pin on the end, if you look at the other side of that pad, you're going to see that it has 2 pieces of aluminum foil in it. That's a dual foil. If it does not have that pin, you'll notice it only has 1 foil. And then all you old timers who are laughing about us taking these things and modifying them for our own test rigs back in the day, I know what you're thinking. I know what you're thinking, but we're not going to do that. We don't need to do that anymore. Matthew, I hope I answered your question. If not, buddy, please follow up with it.
Okay. And Justin, can we talk a little bit about high frequency or?
Oh yeah.
Okay.
So
perfect.
let's crank right into that now. So
Okay.
we all do electrical safety testing, but we need to talk about high frequency leakage. So on the second to the last page, this is the last page, on this page. So when we talked about leakage from the top, down here at the bottom, high frequency leakage. So when we're testing for normal electrical safety, we're testing for 60 hertz energy. That's what all the wall outlets in the United States produce, is 60 hertz. If you're overseas, other countries, you might hear 50 hertz. I think there's still one city in the United States that uses 50 hertz, but there's only one. That's a bonus question if you know where it's at. So we're testing at 60 hertz. The your ESU though is operating probably somewhere in the 2.5 to 3.5 megahertz range. So energy responds differently at that high frequency, where it's flip-flopping its polarity super, super fast. Energy responds differently and acts differently. So not only do we have to check to make sure the line voltage or 60 hertz energy isn't leaking to the outside of the chassis, we now also have to check to make sure that high frequency energy is not leaking to the outside of the chassis. Now, with that, we need to do some things a little bit different here. So we're going to go ahead and set up. It's easiest to do this from the service mode. If you can't get into service mode, you don't have a service mode, you can still do it this way. We're going to go ahead and put our cable like such. Now, in high frequency, and everybody who has an RF generator, radio frequency generator, you have to be very mindful of your cables, because as you cross your cables or intertwine your cables, remember these high frequencies, you're going to transmit from one to the other and you can throw off your readings. So you want to make sure that your cables are not crossed at all, if at all possible. The next thing, we talked about this earlier, we don't want to add any length because we just turned it into a larger antenna and we're going to transmit more energy. More importantly on this, we're not stacked. And if possible, you do not want to be on a stainless steel back table, especially having the 2 units in the same stainless steel back table. You might want to have them on 2 separate, so you're not transmitting from one through the table into the other device. So try to have them separated. Don't add length. I'm going to simply take this set and I'm going to take my REM cable and connect it, and I'm just going to leave it lay on the ground, lay out of the way. I'm going to set it over here so I don't cross my cables with my cup of coffee. Then I'm going to take my variable low and I'm going to use a green cable because I'm going to go to the chassis ground of my ESU, like such. And if you look back in your bag of cables, you're going to see that you have some alligator clips. So I'm simply going to put the black one on my green cable, because red for me signifies hot or energy. So I'm going to go to my ground, and then on the back of my ESU, I'm going to find that ground lug and I'm going to connect it in. Right now, I'm just going to put this pin right here into my known ground. There we go. Good to go. Next thing I'm going to do is I'm going to take a red cable and I'm going to connect it into my variable high of my ESU, like such. On my QAS3 in, I'm going to go back and I'm going to go to HF leakage, high frequency leakage, F3. It's going to automatically put a 200 ohm load on my QAS3. And then I'm going to look into my service manual. I'm going to test all the outputs of my ESU at max output, worst case scenario. So it'll tell you which one to do first, but normally monopolar cut here. I would run this up to my max wattage, start continuous here, activate my ESU, and I want to have less than 150 milliamps. Stop here, and then I'm gonna have to test monopolar 1. Oh, again, you might have to use this, and if we have to do that, we might have to switch over to that bipolar activation cable. Here we go. So I can put this into here, and we'll simply replace this. Start continuous, activate monopolar 1 at max output, and then we're going to go down to bipolar. And then bipolar, it's a little tricky because we have to remember bipolar is putting energy out of both ports and it's alternating it back and forth. So I'm going to connect this to variable high. I'm going to check this port, and then I'm going to check this port. And then I'm going to go ahead and go over to ligature and check their 2 ports. And that's I'm going to check for high frequency leakage from the chassis. This leaves cross coupling, and cross coupling messes with a lot of people. But here's the generalities of what we're trying to accomplish with 2 minutes left. We want to make sure when we activate monopolar 1, the energy is not coming out of monopolar 2, ligature, or bipolar. So if you read the service manual, it's going to tell you something like set monopolar 1 at max output for cut, connect into monopolar 2, hit start continuous here. Oh, start continuous here. Activate monopolar 1 and make sure you have less than 150 milliamps coming out of monopolar 2. And then deactivate your ESU, move down and check the bipolar ports and make sure no energy is coming out of your bipolar, and then no energy is coming out of your ligature. And then it'll probably have you move over to monopolar 2 and check this port, these ports, and this port. If you take your time and digest what you're trying to do, the general basics of it, what we're trying to do is make sure that if we activate this, no energy is coming out of our other ports. If we activate ligature, no energy is coming out of these ports, and around the block that we go. So take your time, look that through. It's a little confusing how the manuals are out sometimes, but once you really look into it, you'll figure it out in a hurry. Whew, 1 minute left. How'd I do?
Wonderful, Justin. Wow, we had quite a few questions that came through, and we do apologize that we wasn't able to get to all of your questions. However, we do want to remind you that feel free to go to our website, flukebiomedical.com. If you click on the Knowledge Center, there are additional resources that are available to you, which includes white papers, videos, and additional training. At this time, this will conclude our webinar today, and we would like to thank everyone once again for participating. Thanks, Justin.
Thanks all. See you next time.
All righty. Bye, guys.